Today we're going to solve polynomial equations. There's a lot of different ways we can go about solving polynomial equations, but the first way we're going to talk about today is factoring. Well, good thing, because we've just spent a couple days factoring, yes? Okay? Before we can talk about factoring, there's one thing we need to talk about because of the fact we're excuse me, because of the fact we're solving, we need to know how many answers we're looking for. There's something called the fundamental theorem of algebra. How important do you think that is? Super, because it says the fundamental, it's actually called the fundamental theorem of algebra. Okay? The fundamental theorem of algebra says whatever the highest exponent is, which is also called the degree, whatever the highest exponent is, that's how many solutions you should find. So for this problem, how many solutions do you think we should find? Three, because that's the highest exponent, right? Now, if you were solving this problem by yourself, you're not, but if you were, what would you do first? Knowing that I'm telling you right now that we're solving it by factoring.
Group.
Greatest common factor? Does this problem have a greatest common factor? Are they all divisible by the same thing? What is the greatest common factor of this problem? Just 2? Oh, 2x, absolutely, right? So if I factor out a 2x, if I divide 2x into each one of these terms, what am I left with? X squared minus 6x plus 9, right? Well, this looks a whole lot easier to factor than that thing does, doesn't it? Because isn't this what we spent yesterday factoring? Okay? So what does it factor into? Well, what's AC? 9. And what's B? -6. So what two numbers multiply to be 9 and add to be -6? -3 and -3, and since A is 1, what can I do? I can go straight to my factors, can't I? I don't have to factor by grouping this time because I can go straight to my factors because A is 1. Do you remember that? Good. Now there's something that you need to know called the zero product property. Okay? There's like 3 famous theorems and properties that you have to know for just today's lesson. That should tell you that it's pretty important, right? Okay. The first one was the fundamental theorem of algebra. And what does that say?
That's how many answers.
The highest exponent is how many answers you should get, right? The next thing you need to know about is called the zero product property. The zero product property, well, let's think about the words for a second. The zero product property. Zero product. What am I doing if I'm talking about a product?
The answer.
Multiplying, right? So if I'm multiplying some things together and I get an answer of 0, what's the only way that can happen? How can I multiply two things together and get an answer of 0?
You're multiplying it by 0.
One of those things has to be 0. It's exactly right, okay? Now, could they both be 0? Yes, they both could be 0, but at least one of them has to be 0. So which one? Do I just get to pick and choose? No, I have to make sure it's all of them, right? I have to decide, well, maybe it's all of them, okay? So what I need to do is I need to take each one of these factors, because I can't do anything else, right? This is as low as this problem can go. I need to take each one of these factors individually, this one, and this one, and set each one of the factors equal to 0. Okay? So this first one I will divide both sides by 2 and get x equals what? What's 0 divided by 2?
0.
0. This second one I need to add 3 to both sides. So x equals 3, right? 0 plus 3. And this last one I need to add 3 to both sides. So x equals 3. So how many solutions was I supposed to get? 3. And how many did I get?
3.
Now, sometimes people want to argue with me about this. Why?
Because 0 is not technically a solution.
Oh, for sure it is, and I'll prove it in just a second, but that's okay. All right? What do people usually want to argue with me about? I got 3 twice. Is that really 2 separate solutions? It is. It is. Okay? Because in order to get this equation, I had to start with 2 separate 3's to get up to that equation, right? Okay? So 1, 2, 3 solutions. I was supposed to get 3 solutions, and I did. Okay? Now, I want to show you something. You're not doing anything yet. You're just watching. Okay? Well, in a second. X raised to the 3rd minus 12x squared plus 18x. Do you notice anything about this graph of this function? It's nice and smooth for sure, isn't it? Okay. Where does it cross the x-axis? 0 and 0 and 3? 0 and 3? So I could use the calculator to help me find my solutions? Is that what you're telling me? Uh-huh. Yeah, we're going to today. That's why I have the note on the board that says make sure you have your calculator out, right? Okay. Any questions about this problem to begin with? Now, we need to talk a little bit about vocabulary, okay? These, first of all, this row right here, those are my factors, right? This row right here, it seems like it has like 12 names, okay? It doesn't. It has at least 3 that I know of, okay? These are called zeros. Do you see why they're called zeros? Because they cross the x-axis. When x is 0, this is, sorry, when y is 0, these are the x values that it's crossing at. Does that make sense? Okay. Plus, I set it equal to 0, and this is what I got. So does that make sense why it would be called zeros? They're also called roots. They're also called x-intercepts. So I try to be careful and call them either zeros or roots because that's the words that I'm most familiar with. But can you see why they would be called x-intercepts? This is where it's crossing the x-axis, right? So be careful what they're asking you for. Because if it says, here's this equation, I want the factors, you stop right here, don't you? Because those are the factors, right? But these are the zeros or roots or x-intercepts. Any questions? Or I could just say solve. And if it says solve, it wants x equals. Does that make sense? Okay. Well, let's try this one. How many terms are there? 4. Okay, so if there's 4 terms, how do most of you want to try to solve this problem? What? Well, first of all, yeah, absolutely. First, we want to check to see if there's a greatest common factor, right? So look through all 4 terms. Is there a greatest common factor? Not this time, okay? But that's a very good point that you're making. We need to check every time for greatest common factor, right? Okay? But now there's 4 terms. How have we been solving with 4 terms? By grouping, right? Now, I don't want us to write anything yet. I want us to use our brain, okay? If I'm grouping this, I'm grouping these 2 and these 2, right? Well, what's the greatest common factor between these 2 terms? X squared. And if I factored out an x squared, what's my parentheses say? X minus 8, right? And what has to be true about this parenthesis over here? It has to be the same, right? It has to be at x minus 8. So what am I going to divide out of this side so I get a parenthesis that says x minus 8? Yeah, that's exactly the right face, right? Because there's not anything. There's nothing I can divide out of this that's going to give me a parenthesis of x minus 8. To get x here, I'd have to divide out 11, right? But 20 divided by 11 is not 8, is it? So that means I have to have another way. There has to be another way to do this, okay? So this is where we talk about our third important theorem of the day, which is the rational root theorem, okay? Now, I don't want this to be one of those when I was your age stories, but it needs to be, okay? Because when I was your age, we knew the rational root theorem, and I'll show you in a minute, if you really want me to, what I had to do to solve this problem. I'm not having you do it that way because that would be wasteful of the technology that we have with us now, okay? And part of my job, part of the list of the things that I have to do is make sure you understand how to use the technology. So we are for sure going to harness the technology for this lesson, okay? If it's something you can't factor, I want you to think of the rational root theorem. The rational root theorem says instead of just an infinite number of numbers that you could try to guess to try to figure out what the roots are for this problem, we can narrow it down, okay? And we do that by taking all of the factors of this last term, the constant, and dividing it by all the factors of the leading coefficient, the very front coefficient. Does that make sense? Well, what are all the factors of 20? 20 is divisible by 1, right? 20 is divisible by 2. What else is it divisible by? 4, 5, 10, and 20, right? Those are all the things that it's divisible by, isn't it? But isn't this also divisible by -1 and -2 and -4 and all the negatives of the numbers that we just found out? So we're going to write plus or minus, 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 plus or minus. The rational root theorem says I have to divide all of the numbers of the constant by the numbers of the leading coefficient, all the factors of the leading coefficient. Well, in this problem, what is my leading coefficient? 1, right? That's right, okay? So I need a plus or minus 1. Well, guys, if I'm dividing anything by 1, what do I get? I just get itself, right? So I have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. Now, 2, 4, 6, 8, 10, 12. 12 still seems like a lot of numbers when I'm only supposed to be finding how many? 3, right? Fundamental theorem of algebra says the highest exponent is how many solutions I have. Now instead of an infinite amount of numbers, now I only have 12 to try to figure it out from. My 3 answers should be on this list if they are rational. Okay? The other option is irrational. We haven't even gotten there yet, so we're not going to talk about that yet, okay? So I'm telling you right now, all of our answers, because we haven't gotten to irrational numbers to talk about yet, all of our answers will be on this list, okay? So what I had to do at this point is I had to do synthetic division with all of these numbers until I found 3 that had what as the remainder? 0, right? Would you like to do 12 long division or synthetic division problems, or at least to find 3 for one problem? Yeah, I don't either. But that's what I had to do. I'm not complaining. I'm a better person because of it, right? I'm really good at synthetic division because we had to practice it a lot. Okay? But here's what I know that we can do. We can harness the technology, and we can go to our calculators. I would like you to do this with me, okay? I'm not performing for you. I'm showing you how to do this problem, so I want you to do this with me. So in your calculator, I want you to put in x raised to the 3rd power minus 8x squared plus 11x plus 20. Now, when I graph it, what am I looking for? It's where it crosses the x-axis, right? Where does this graph cross the x-axis? -1, 4, and 5. Do you see that? How many solutions did I just find? How many am I supposed to find? 3. Did I just find all my solutions? Yes. Now the last thing that I'm asking you to do is to prove it. I know your graph says that that's where they cross. I need some work here. All right? So I am asking you to do some synthetic division. Good thing you know how to do it, right? 1, -8, 11, and 20. But I'll even teach you a trick, because how many times does it look like you're going to have to do synthetic division? 3. I'll even teach you something, a way to do it so that we're only going to have to do 2. So instead of 12, I'm asking you to do 2. Is that all right? Okay. So first of all, these are, what are these called again? Zeros. I also want you to list the factors, because we still need to focus on stuff like that. Okay. So remember, go back up here, if my factor was x minus 3, what was my 0? 3, right? So if my factor is -1, sorry, if my 0 is -1, what's my factor? X plus 1, right? If my 0 is 4, what's my factor? X minus 4. And if my 0 is 5, what's my factor? Very good. Okay? This is proof that these are true. Are you ready to see how I want you to do this? So let's start with -1. We could start with any of these 3. I just know that the smaller numbers are typically easier. Okay? So synthetic division, I pull this number down, multiply these 2, write it here, and add. Multiply these 2, write it here, and add. Multiply these 2, write it here, and add. Didn't I expect a 0 right here? Right? And I could have even filled it in early just to tell myself, hey, this should be 0. Okay? Now here's what we're going to do instead of another full synthetic division problem. I'm going to start from here. Does that make sense? I'm starting from the answer that I got using a 4, using my next 0. So pull down the 1, 4, -5, -20, and 0. This is proof that all 3 of these zeros work, because what does this translate back into if you write it into an equation? This is my remainder, so this is my constant, and this is my x term. This says x minus 5. Isn't that what that factor is right there? Any questions? So I just want you to understand that you have the problem that you have to write. You have to write the possible rational roots. You have to write your zeros and your factors that you find, and you have to do basically 2 synthetic division problems instead of 1 for every single one of these possible factors. You're welcome. Does everybody understand what's expected of work? Yes? Okay, let's do another one then. X cubed minus 10x squared plus 19x plus 30. Is there a greatest common factor? No. And can I really want to check just to make sure, can I factor it by grouping? Because if I can factor it by grouping, isn't that way faster? It is, right? Okay, can I factor this by grouping? If I factor out an x squared, I get an x minus 10. Can I get an x minus 10 right here? No. So first thing I have to list are my possible roots, right? All possible roots. So all the factors of 30, 1, 2, 3, 5, 6, 10, 15, and 30. Do you see that I'm trying to match up the partners? 5 and 6 make 30, 3 and 10 make 30, 2 and 15 make 30, 1 and 30 make 30. Yes? All divided by the factors of the first term, the leading coefficient, which is what? 1. So I get 1, 2, 3, 5, 6, 10, 15, and 30. So I had an infinite number of possibilities. Now I only have 16, right? And what's going to help us narrow that down even further? Your calculator. Okay? So in the calculator, I'm hitting tab, and then I'm going to hit my up arrow so that graph goes away. I have my x raised to the third minus 10x squared plus 19x plus 30. Okay, somebody who hasn't answered yet, please tell me where you see a 0. And just one at a time. Where do you see a 0? A negative 1. Somebody else who hasn't answered yet? 5.
6.
And 6. How many am I supposed to have?
3.
How many did I find?
3.
Perfect. These are my zeros. What are my factors?
X plus 1.
X minus 5, x minus 6. These are zeros. These are factors. So what am I going to do with my zeros now? Synthetic division. 1, negative 10, 19, and 30. So 1, multiply, add, multiply, add, multiply, add. You want to do 5 or 6 next? Does it matter?
No.
It does not, right? Because they should all be zeros right here. So 5. So 1, 5, negative 6, negative 30, 0. What does this say right here?
X minus 6.
And is that my third factor? So then that's all the proof I need. Any questions? I'd like to do one more because this is going to hit 2 topics that we really need to talk about. Okay? 3x to the third plus x squared minus 38x plus 24 equals 0. 3x to the third plus x squared minus 38x plus 24 equals 0. What's the first thing I think about? Greatest common factor? Is there a greatest common factor? Well, as soon as you see a 1, you know there's probably not a greatest common factor, right? Okay? Could I factor it by grouping? Could I factor out an x squared and get 3x plus 1? Is there anything I can divide this by, make it become 3x plus 1? No. Okay, so I need to do what we have been doing, right? All the possible rational roots. What are they? The factors of the last term. What are the factors of 24? 1, 2, 3, 4, 6, 8. Good. And 24, right? All divided by the factors of the first term, the leading coefficient. This time, there's a number there, isn't there? It's not just 1. So what are the factors of 3? 1 and 3. So that means I have to divide everything in the numerator by 1, and then I have to divide everything in the numerator by 3. Well, what's everything in the numerator divided by 1? Just itself, right? So I have 1, 2, 3, 4, 6, 8, 12, and 24. Now I have to divide everything in the numerator by 3. What's 1 divided by 3? 1/3, right? What's 2 divided by 3? 2/3. 3 divided by 3? Well, I already have that, so I don't need to write it again, right? 4 divided by 3? 4/3. 6 divided by 3? 2, I already have that. 8 divided by 3? Oh, I'm running out of room. 12 divided by 3? 4, I already have it, right? And 24 divided by 3? 8. I already have it. So now, while that still looks like a really long list, what was the option? What was the alternative? Infinity, right? And I think you would always choose this out of infinity, yes? So what are we going to do now? Narrow it down, right? We're using our calculator. Okay. Three x raised to the third plus x squared. Dang it.
I have a question.
Plus x squared. Hold on just a second, please, okay? Minus 3ax plus 24. What's up?
Couldn't you just put it in the calculator as soon as you see it?
I mean, you could, but you're not following the instructions I'm asking you to follow. Yeah. It's important that you know rational root theorem, so that's why I'm having you write all the possible rational roots. Okay? So, what are, somebody who hasn't talked yet, what could I do? What are my rational roots? Negative 4. Okay, so how many am I supposed to find? How many did I find? Why didn't I say anything about this one? Is it crossing at a point, at an integer? It's not, right? So I don't know for sure. I could assume, but I don't want to do that, right? But I'm not worried about it because I can go find that 0, right? I can go find that other 0 by using my synthetic division, right? So negative 4. So I've got 3 and 1 and negative 38 and 24. So 3 and negative 12, which is negative 11. And this is 44, which is 6, which is negative 24, which is 0, which is what I need. So we're good. And then this last one with 3. So I've got 3 and 9 and negative 2 and negative 6 and 0. So my roots, or my factors.
X plus 4.
Very good.
X minus 3.
Very
X
good.
plus 2.
What does this say?
2 over 3. Or 3
If
over
this
3.
is my constant and this is my x value, what does this say? 3x minus 2, right? Well, if I set that equal to 0 and solve it, won't that give me my 0? 3x minus 2 equals 0. 3x equals 2. X equals 2/3. Wasn't that on my list? Yeah? Was it in a place that I could have assumed that that was 2/3, being as I know my rational roots have to be on this list? Right? It's not 1/3. It's not closer to the origin. It's closer to 1, right? But do we assume? We don't. And there may be times where there's numbers that are close to each other. Maybe it was 2/3 and maybe that was 3/4, right? Maybe there was that other thing on my list. I definitely can't assume there, can I? Okay, so just use your synthetic division to go find the answer. Any questions about this?